Hi, welcome to my report on Mechatronics Practical number 5, the sorting station. The aim of this laboratory was to create a PLC program that would successfully run the Festo sorting station. The sorting station itself is an electro-pneumatic device capable of detecting the colour of specific pieces placed on its conveyor belt. Based on the colour detected, these pieces are then sent down specific chutes as required. The sorting station comes equipped with start, stop and reset buttons on the side, as well as lights on both the reset button and the start button that help to indicate what point the program is up to and when it's ready to progress. On the main body of the sorting station there is a conveyor belt run by an electric motor. There are also two pneumatically actuated arms that help direct the pieces down the specified chute. A small pneumatic stopper is located near the magnetic and light sensors used to detect what type of piece is currently in the sorting station. There is also a light sensor at the entrance to the conveyor belt and the top of each chute to detect when either a piece is available or when the chute is full. To operate the sorting station, it was required that 2 STL programs would be written, as well as any number of CMPs, or call function modules, as required. P0 controls most of the start, stop and reset functions of the sorting station. In order to do this, it is on a constant loop and never stops at one step for any period of time. P1 controls the actual sorting of the sorting station after the start button has been pressed. While P0 is on a constant loop, P1 is activated by P0 and runs through its specific set of instructions until it has reached the end of its cycle. It begins by checking if the station's reset status is OK. If it detects that the station is not considered ready, P1 loops until the reset button has been pressed. Once it detects that the station has been reset, it goes on to check that the start flag is active. If the start flag is not active, it turns the start light on and waits for a response from the start flag. Once it detects that the start flag has been activated, there is a quick side set of instructions to ensure that the program does not run while the slide is full. Under the condition that the slide is not full, it will wait to see if a part is available, and once a part is available, it turns on the conveyor belt. Once a part has been detected, it then moves on to the stopper where the sorting station decides if the part is metal and if it is black. Based on the outcome of these two sensors, either the first gate, the second gate, or neither gate is activated. The sorting station then has a short delay before retracting the stopper and sending the piece down its specific chute. Finally, as P1 detects the slide full indicator becoming active, it finishes its cycle. So now let's move on to watching the program run. For this demonstration, we'll run through sorting one piece for each colour. In the corner is the online display while the program is run. On this, you can see the programs themselves running, but more important, the online display of the inputs and the outputs. This shows when a button is pressed, when a sensor is activated, or when one of the outputs is set. Each time the program reaches the end of a cycle, or the end of P1, and a piece has been successfully sorted, the start light comes back on, letting you know the sorting station is ready to proceed. We can also see that the very first time the program is run, the reset light is on, and thus the reset button needs to be pressed. Once the reset button has been pressed, the start light comes on, letting us know the program is ready to begin. If the program is stopped while a piece is being sorted, it needs to be manually removed and the entire station reset before it can start again. When the slide is detected as being full, the start button is unable to be pressed. With little more effort, a few features could be added to the sorting station to increase its functionality. Firstly, the sorting station could be given an automatic setting so that the start button does not need to be pressed each time a new piece is added. Due to the specified requirements of this project, The start flag may not be activated while the sorting station detects that a part is available. While this is set as a requirement, it seems more logical to allow the start flag to be activated while a part is available. This would allow for smoother operation of the sorting station, as the operator would not have to make sure that the start button has been pressed before setting the piece. Overall, the sorting station successfully meets all the design requirements. It is able to, without fail, sort each piece by colour and send it down the required chute.